We're talking about one of the greatest triumphs of modern medicine, a revolution that absolutely changed healthcare forever. But today, these miracle drugs are facing a crisis, a threat that could, seriously, send us right back into the dark ages of medicine. This is the story of antibiotics, both the miracle and the menace.
So let me ask you something. Could a paper cut kill you? I know, it sounds like a ridiculous question today, right? But for most of human history, the answer was a terrifying yes. And that simple question, it really gets to the very heart of why we need to talk about what's happening with our most powerful medicines.
To really get a handle on just how miraculous antibiotics are, we have to take a step back in time. We need to try and imagine a world that our great-grandparents knew all too well, a world without cures.
I mean, just think about that for a second. Strep throat could lead to heart failure. A simple skin infection from a scrape could lead to amputation. Pneumonia? It was a massive killer. Without any real way to fight off bacteria, medicine was often just a spectator sport. Doctors could only watch and hope the body's own immune system could somehow win the fight on its own.
And then, in the 20th century, everything changed. A series of incredible discoveries gave humanity this powerful new weapon against our oldest enemies, and it really marked the dawn of miracles in medicine.
What's so wild when you look at this timeline is just the incredible speed of it all. It kicks off in 1935 with Prontosil, but then we're quickly finding drugs like streptomycin just by digging around in the soil. By the 50s, we have these broad-spectrum antibiotics, and then by 1961, ampicillin makes it so you can get powerful treatment in a simple pill. It was truly a golden age of discovery.
And this wasn't just about curing infections anymore. Antibiotics became the absolute bedrock of modern medicine. This number, 34 million prescriptions in just 1 year in the UK. It's what makes complex surgeries, chemotherapy, and even organ transplants possible because they prevent those deadly infections that could happen after.
So how do they work their magic? What's the secret sauce? Well, it all comes down to a crucial principle called selective toxicity. It basically means these chemicals are like perfectly engineered assassins. They're designed to attack and destroy bacterial cells while leaving our human cells completely alone. That is the genius of it.
And they've got a few main strategies for their attack. Some act like a wrecking ball, just smashing the bacteria's protective outer wall. Others are a bit more subtle, poking holes in its membrane. Or they go for an inside job, sabotaging the internal machinery, stopping the bacteria from building what it needs to survive, or preventing it from copying its DNA to reproduce.
But, and you knew there was a but coming, right? Here's the twist in our story. For every action, there's a reaction. And as we got better at waging war on bacteria, well, the bacteria started to fight back. They started evolving defenses that would create a brand new enemy, the superbug.
So how does a regular bacterium become a superbug? Well, there are two main paths. The first is basically a lucky accident for the bacterium, a random genetic typo, a mutation that just happens to protect it. When an antibiotic comes along and wipes out all its neighbors, this one resistant survivor gets to multiply and take over. The second way, and this is the really scary, fast way, is something called horizontal gene transfer. Instead of just passing defenses down to their kids, bacteria can literally share their survival secrets with their neighbors, even if they're a totally different species. It's like they're passing around a cheat sheet for how to survive our drugs in real time.
And what's on that cheat sheet? A whole toolkit of survival gadgets. Some bacteria learn to change the shape of the very thing the antibiotic is trying to hit, so it just glances off. Others develop these tiny little pumps to spit the drug right back out as soon as it gets inside. And some even create special enzymes that are like molecular scissors, literally cutting the antibiotic to pieces before it can do any damage.
And look, this is not some theoretical future threat. It's happening right now. You've probably heard of MRSA, that nasty skin infection. But there are others, like drug-resistant Streptococcus pneumonia, a major cause of pneumonia that's getting harder and harder to treat, and Acinetobacter, a bug that just loves hospitals and is famous for being resistant to almost everything we can throw at it.
The stakes really could not be higher. This quote from David Cameron, the former UK Prime Minister, just captures the urgency perfectly. We are in a race, a serious race against an opponent that evolves millions of times faster than we do.
So, what's the plan? How do we possibly stay ahead in this evolutionary arms race? Well, the good news is scientists are exploring brand new weapons and brand new strategies to fight back.
Okay, so one of the most promising new frontiers is this class of molecules called antimicrobial peptides, or AMPs for short. And the really incredible thing about these is that we're finding them by studying bacteria themselves. See, bacteria produce these little proteins to wage war on their own competitors. So we're essentially learning how to use nature's own weapons against itself.
So how do these new kids on the block stack up against our traditional antibiotics? Well, they've got some huge advantages. On the left there, you can see they often work by physically shredding the bacterial membranes. It's a brute force attack that's much harder for bacteria to evolve resistance to. But there's a downside. They can be really unstable and expensive to produce. So, while they're an incredibly powerful new tool, they've got their own challenges. To find more of these new compounds, we've had to get really creative. This thing called the iChip, for instance, is this clever little device that lets us finally grow the 99% of soil bacteria that we could never get to grow in a lab before. And it's already led to the discovery of teixobactin, a seriously potent new antibiotic. At the same time, we're mining the genomes of bacteria and realizing, wow, they have the genetic instructions to make dozens of antibiotics we've never even seen. The cures might have been right under our noses this whole time.
And this brings us to the ultimate crossroads. We have the science, we have the ingenuity to discover a whole new generation of miracle drugs. But bacteria, they have the raw power of rapid, relentless evolution on their side. The one question that's going to define the future of medicine is the one you see right here. Can we innovate faster than they can evolve?